Okay, so we have all the good intentions of wanting to reduce the greenhouse gas emissions, but there is also the factor of population which may increase, and as standards of living go up, the number of calories consumed as well as wasted tends to go up as far as the history of us is considered in the last century. And the agricultural production system emits about 25% of the total emissions that are occurring right now. So this is a nice report by the WRR, World Resource Research Institute, I think. It's showing 1 million tons of CO2 equivalent per year. So you convert all the other greenhouse gases into CO2 and make it a CO2 equivalent. Using the 2010 as a base year, they show the emissions happening from ruminant enteric fermentation. So cattle, which have a two-chambered digestive system where they go around gobbling everything they can smell as food, they have an additional gland in the top of their mouth called the Jacob's organ, I think, which they open their mouth and smell things. And in India, you see them eating plastic, cardboard, and all kinds of garbage because probably it has food smell. Okay, and then when they are sitting down and resting, they vomit that food from that chamber and chew it down into the digestive chamber. Very inefficient process and emits lots of methane from that process as well. There is the ruminant waste on pastures. So now with increased meat demand, with increasing standards of living, the industrial farming goes up, industrial cattling cattle farming goes up, same for poultry farming. Manure management, energy use in food production system, soil fertilization in terms of nitrogen and phosphorus and causing emissions into the atmosphere, and methane from rice paddies. Rice remains staple food for a huge fraction of the world's population, and the most popular method of growing rice is to flood the fields to avoid the weeds, drown them out, and that ends up producing a lot of methane, which is converted into CO2 equivalent as well. Okay, so in the 2010 base year, you have significant amount of ruminant enteric fermentation happening, contributions from ruminant wastes, manure management, energy consumption is significant, soil fertilization, and rice methane emission. The projections into 2050 as a baseline assume certain things which I'll show here. The 2050 baseline reduced growth in demand for food and other agricultural products, shift to healthier and more sustainable diets, avoid bioenergy competition from bioenergy for food, crops, and land, achieve replacement level fertility. So that's more to do with population, and that affects obviously food demand. Nonetheless, if you do all those good things, you might end up with increasing production but also increasing emission pretty much in each category. So this has gone up, this has gone up, so all of them have gone up. So you have increased this substantially. But if you don't do any productivity gains along the way by genetic engineering, by various other sustainable methods used here in the scenario, then you will increase the emissions even further. Okay, why are we going through this? Basically, there is a very strong literature now on what is called food, water, energy nexus, which looks at how the competition for water, for agriculture, and energy affect each other. But it's obvious that food, water, and energy systems must also include human health. So it should actually become the nexus between food, water, energy, and health, because use of water for agriculture and energy creates health impacts directly and indirectly in terms of water quantity, quality, and access. And energy production obviously pollutes and affects direct and indirect effects, as we saw in the fossil fuel impacts. And agriculture, of course, is going to be affecting both of them in terms of water demand and energy demand, as well as there are direct climate impacts on the food quality itself. For example, there is some evidence that even if precipitation increases, increased temperatures can begin to reduce crop yields. Plus, there is also some preliminary evidence that the uptake of micronutrients like iron and zinc and so on, which are really essential for us, may reduce in warmer temperatures. Okay, so health impacts of global warming on crop food quality is going to be affecting human health as well. Okay, though those are the couple of points I wanted to add. Plus, if you look at the local exposure and distant exposure of climate change quantities like temperature change, it impacts physical assets, productivity, and health. So this is still related to food system. Sea level rise can damage physical assets, so infrastructure, buildings, and agricultural production, because sea level rise causes saline water intrusion into the groundwater systems and can cause soil salination. Water scarcity, extreme weather, of course, regulatory and legal risk. Impacts, so that includes new land use or zoning regulation, water use efficiency standards. So as soon as you begin to ask people to behave in a certain way, there are going to be lots of behavioral issues which directly affect health as well, like smoking or running outside in a pollution, eating junk food, and so on, right? So impacts on local communities and workforce, rising insurance policies, financial risk, political risk, and then there are also distant exposures through impacts on markets, reputational risk, and increased competition for resources. So they include increasing price volatility, which has already happened a few times, changing demand and supply of certain goods like water purifiers, irrigation equipment. Company may receive negative media coverage. We talked about Volkswagen emission cheating scandal. So the companies, including the oil companies, fossil fuel companies, are now eager to portray themselves as being green and climate friendly and so on. Okay, that's somewhat of an oxymoron, but still it's important for profitability, right? Increased competition for resources because of increasing uncertainty in production, interrupted transport because of extreme events and other hazards, storms, sea level rise, scarcity of some commodities, and disruption of supply chains. Okay, there is very good examples here. Typhoon Haiyan, which hit the Philippines in 2011, I think we already talked about it, actually affected its supply chain across the globe and directly affected productivity and production in other places in Europe, South America, and North America, and also indirectly affected the supply chain of the finished products based on Philippine imports from the countries that produce those products to other countries. So local and distant exposures and direct and indirect risks shown in these colors are very critical to consider, both in terms of direct climate impacts on food supply quality, water supply quality, access, price volatility, etc. So obviously, again, re-emphasizing the point that these compound risks are very complicated but very important to understand.